I remember hearing about them when I was in early grade school, and they've always been 10 to 15 years away since the 90s. But what I learned is that there are two major reasons why quantum computers have been held back. And the first reason is something called quantum coherence, or how long qubits can hold their quantum state before they collapse. Now, they need to be in quantum state just long enough to solve a problem. And the longer it can be in that state, the more complex a problem it can solve. Now, the second challenge is something called the critical error threshold. And that means the point at which error rates are low enough for us to trust the results of a computer. That means we need something called quantum error correction. Because without quantum error correction, errors are created faster than they can be fixed, which makes it impossible for us to trust the results of a computation. Now, how though does the system know that something is an error, and how does it even correct itself, right? Like, how would a computer even know that? And that gets insanely complicated, but it uses something called syndrome qubits to look for errors in what are called logical qubits. So imagine you have 3 friends, right? I know it's a stretch. And each one writes down the same secret message. Now, if one of them makes a mistake, you can tell which one made the mistake because the other 2 copies match, but the third one doesn't. So you correct the message by replacing the incorrect friend with the correct one. And that's a super simplified explanation of it. And in quantum computing, instead of checking friends, it's checking quantum relationships. And if something looks off, it knows which qubit to correct. Long story short, these 2 problems, quantum coherence, aka how long it's in quantum state, and quantum error correction, have been the 2 reasons why this technology hasn't progressed as fast as we liked it to